Hey everyone, in this video we are solving question 2 from 2024 AP Calculus AB free response section. This is particle motion problem involving velocity function which is basically a Laurent function. We will cover direction, acceleration, position and total distance. So let's dive right. Yes, it's with calculator. So we will be using Desmos today. So be ready with your pen and paper and your calculator, graphic calculator. So a particle moves along x-axis so that its velocity at time t greater than or equal 0 is given by velocity function. So this is velocity function, right? And then that is 1 time t equal to tr in the interval when the particle is at rest. Find that time. And then at that time, it's moving right or left. Give reason for that answer. Then find acceleration of the particle. And is the speed increasing, decreasing, the position of the particle, and then finding total distance. So let's solve one by one. Here we go for the first one. So a particle is moving along x-axis, that its velocity time and velocity function is given. There is 1 time t equal to some tr. And it is lying on the interval when the particle is at rest. Rest means not moving. So particle is at rest means velocity is 0, right? So rest implies velocity 0. V of t equal to 0. That's it. This is the condition. You solve for this and that t value will be your answer. That tr is, we can get it from this. So here we go. Okay, v of t is this function, right? So we need a calculator here. So 4t plus 5, negative 0.2t equals 0. So let's switch to Desmos now. Here we go. So that's v of t, here it's v of x. Okay. So we need v of x to be 0. So where it crosses the x-axis. And your time lies between 0 to 2 is what I have given. So this is what I got, right? So we can use it. Very simple calculation. Let's move to solution page. Let me paste this here. So this is all we got when you equate this to 0. And t is from 0 to 2. So this value is not possible. So it's 1.42561. So this implies your TR is 1.42561. You can take 3 decimal places, but round it off correctly. Don't make error there. Right? So now, the question is not over. Find TR. Okay, we did that. For 0 to t to TR, is the particle moving to the right or the left? So this is 0 to your TR. Okay. In this thing, your particle is moving which side? Right side or left side? Give reason for your answer. Don't confuse with this. This is velocity function. It tells about velocity, how velocity is moving. But this question is position. So which side it is moving? When your velocity is positive, v of t greater than 0, then the position is right. When your velocity is negative, position is left. Right? So here I have velocity positive for this. Why I am telling positive? Because this velocity curve is above x-axis. So yes, velocity is positive. So the position of the particle is at right. That's simple. So we can mention the reason. This reason. When velocity is positive, this looks right. Okay, that's simple. And moving to first part is over. Next. Find the acceleration of the particle at time t equal to 1.5. Show the setup for your calculation. Is the speed of the particle increasing or decreasing at time t equal to 1.5? Explain your reasoning. Okay. Acceleration. We have velocity. V of t is ln natural log t square minus 4t plus 5 minus 0.2t. How will you find acceleration from velocity? Derivative of velocity is acceleration. So A of t is equal to B dash of t. And we need to show up our calculations. So we have to apply chain rule because it's ln of a function of some other thing, right? So B dash of t is 1 over t square minus 4t plus 5 times differentiate that part t square minus 4t plus 5. So that differentiation you can write to the top, just 2t minus 4. Then minus 0.2 when you differentiate, it's minus 0.2. Right, so this is my A of t. Okay, right. Next, we need to find speed, acceleration at t equal to 5. So what is A of 1.5? You can use calculator. 2 times 1.5 minus 4 by 1.5 square minus 4 times 1.5 plus 5 minus 0.2. The simple calculation. So you solve this, you will get minus 1. Okay. A of 1.5 is negative 1. Now, is the speed of the particle increasing or decreasing at time t equal to 1.5? Okay. A of 1.5 is negative. And we will compare like speeding up or slowing down. This is, we will compare acceleration and velocity sign. Correct? Sign of acceleration and velocity. So A of 1.5 is less than 0. Just now we have calculated. What is V of 1.5? We can check that from our graph. Let me show you. We already graphed V of t, right? So V of 1.5. So this is 1.4. After that, it goes below. So 1.5 is less than 0. So V of 1.5 is less than 0. Okay. If same sign, it's speeding up. If A and B have same sign, speeding up. That's the rule. So same sign, it implies speeding up. And we can say speed is increasing at that, like at 1.5. Speed is increasing at 1.5. Like when t is equal to 1.5, I mean, that's simple. We covered this part also. Right, moving to next. The position of the particle at time t is x of t, and its position at time t equal to 1 is minus 3. Find the position of the particle at time t equal to 4. Show the setup for your calculation. Let's go. Right. So from velocity is given to us. From that you have to go to position. So anti-differentiation. So V of t is equal to ln t square minus 4t plus 5 minus 0.2t. Okay, you need x of t. X of t means you integrate V of t dt. That's it. Okay. Now it's not an indefinite integration, definite integration. So let's we have from time 1 to time 4. So 1 to 4, I am applying fundamental theorem. V of t dt is what is antiderivative of V of t? Position x of t. 1 to 4. So, and this you can write x of 4 minus x of 1, right? When we plug in the upper limit minus lower limit. Actually, I need to find position at time t equal to 4. So, we need x of 4. So, make x of 4 as a subject. X of 4 equal x of 1, like we are taking this here, plus integral 1 to 4 V of t dt. So, position at 1. Then from 1 to 4, area under the velocity curve. So this is the important thing from fundamental theorem of calculus. Okay. Right. So what should I do with this? Yeah, x of 4 is our range. X of 1, it's given to us. When t is 1, x of 1 is minus 3. So we can plug in. This one, we need calculator help. So x of 4 is minus 3 plus integral 1 to 4 V of t dt. Right. So let's go to decimals and solve for this. Okay, my V of x is ready. Now integral. So you type int and your lower limit is 1 to 4 and we are going to differentiate v of x. So also you should give dx. Okay. So we got 0.19 this thing. Final value I need to calculate minus 3 plus this stuff. Okay. So let me add minus 3 also here. Minus 3 plus. So we got negative 2.80. So full calculation is done here. Let's go. Okay, there it's t. Here in Desmos, I used x. I hope you can understand the convention of the variable. Okay, here we go. So this is what we got for this. And finally, you can make it to 3 decimal places. So it will be negative 2.803. The position of the particle is this much. If unit is given, we will mention the unit from this. So, but it's not necessary for a question. That's it. Now, last part. Find the total distance traveled by the particle over the interval 1 to 4. Show the setup for your calculation. Okay, total distance traveled. When it's ln function, every function you should use modulus. That's the key thing. It's integral 1 to 4 modulus rate change of the function, right? V of t dt. And we need to calculate this. So don't confuse with 1 to 4 we did here. It's without modulus. With modulus, we'll have a huge difference. So irrespective of the direction, we should cover every thing. Okay. So if you don't use the modulus, some minus values, they will get cancelled out and the value will be absolutely wrong. So always use modulus, I mean the absolute value. Okay, again we are moving to Desmos to complete the problem. So this time it's not, it's integral again. It's not needed. Integral again 1 to 4, but total distance means modulus of rate function. So distance rate function is velocity, right? V of x. So I define the function as v of x. So I'm using. So we got this. Okay, let's do what if it's without modulus. Okay, integral 1 to 4 v of x dx without modulus. You see the difference? So total distance means here we got this. So the negative things will be cancelled out. Modulus, so absolute value. Distance means always absolute value. This is wrong. So rejecting this, this is the correct. That's it. With this, we come to the end. So let's complete the problem. From graphical thing, we got this. This is a cursor. So it's actually v of x here. Okay. So this is 0.95813 and so on. So when you approximate it, 0.95 to 3 decimal places. This is the total distance traveled by the particle. Show the setup for your calculation. Yeah, you can show the setup. So total distance formula, this modulus is important. Right? So that's simple. And with this, we come to the end. So we have covered, let's quickly review what we did. So in this question, it is a ln function. So velocity is given. We have interpreted acceleration, position, and then we also find the total distance traveled by the object. So this is an important topic. And yes, so that's it for today. I hope this video might be helpful to you. If this helped you, make sure to like the video, subscribe, and check out the full FRQ playlist, which is given below. Keep practicing. I will see you in next video.